Hello class, today we are looking at volume, specifically volume of right prisms. So how do I find the volume of right prisms is our essential question. Your learning intention. I am learning to find the volume of any right prism. We've got two warm-up questions, so these are taking you back to the trig functions. Please pause the video and see if you can do those on your own. I do hope you tried. Remember, sine is the opposite length over the hypotenuse. Your cosine cosine, C-O-S. I was giving you the acronym. Is your adjacent over your hypotenuse. And finally, the one that does not use the hypotenuse at all is our tangent. Your tangent is the opposite over the adjacent. Okay, so it says a 50-foot pole has a support wire that runs from its top to the ground with an angle of depression of 75 degrees. How far from the base of the pole does the wire connect? And how long is that wire? So, you've got a 50-foot pole, angle of depression, and you're wanting to know how far and how long. So let's draw our picture. Okay, here we go. Here's your 50-foot pole. Here's your angle of depression. Here's your where it attaches to the ground, and here is your hypotenuse, which would be the length of the wire. So if we're going to find A first, the first thing we've got to realize is the angle of depression and the angle of elevation are alternate interior angles of parallel lines, and they are congruent. So second, for A is a side. I know the other side. That means to find it, I will use the tangent ratio. The tangent of 75 degrees is equal to 50 divided by A. If you remember what I told you to do, every time you've got your variable at the bottom, we flip-flop. So, A is equal to 50 divided by the tangent of 75 degrees. And we end up with 13.39. We're going to round it up to 13.4. So, the guy wire, or the support wire, is attached about 13.4 feet from the pole. Okay, now, that's the first one. Second one is, how long is that wire? How long is the wire is B? I'm still at this 75 degrees, B is my what? B is my opposite. Or 50 is my opposite, B is my hypotenuse. My pole had better be at a 90-degree angle to the ground or it will fall over. So this is opposite and hypotenuse. Opposite and hypotenuse is my sine. So the sine of 75 degrees is equal to 50 divided by B. Once again, we're going flip-flop. So B is equal to 50 divided by the sine of 75 degrees. I'm going to just go back and change that to sine. And it is 51.76, which is approximately 51.8. So the wire is about 51.8 feet long. Okay, I should have left more room there so we could write those sentences out. So the next one is actually a compound problem. The angle of depression on one side of the lake measured from a balloon that is 2,500 feet above the lake is 43 degrees. The angle of depression to the opposite side of the lake is 27. Find the width of the lake. So if we're looking at, here's your angle of depression. This is the first one, that would be 43. So this one has to be 43 also. For the second one is 27, so this has to be 27 degrees also. Yeah, it's kind of hard to see the 27 degrees, but we know it's there. Okay, so now let's look at it again. The angle of depression, and the balloon is 25 feet above the lake. 2,500 feet above the lake. One angle of depression is 43. The other angle is 27. So what we're wanting to know is this length here. Okay, so it's actually two problems. You've got to use, because we're wanting to know this is your hypotenuse and this is your adjacent. Both times we use adjacent and hypotenuse. So that is our cosine. Cosine of 43 degrees is equal to x over 2,500. Okay, to do the opposite, I've got to multiply both sides by 2,500. (2,500) times the cosine of 43 degrees gives me 1,828.4. Okay, we do the same thing again. This time we use the 27 because that will give us the whole distance down here. Okay, once again, multiply both sides by 2,500, 2,500, And this is 27, not 43. I'm so sorry. Because that's that other angle there. And we get 2,227.5. I think I need to change this. If this one's X, we need to call this one Y. Okay, now I know the whole thing. I know this piece. I now have to subtract to find the distance across that lake. And it is 399.1. So, what I know is the distance across the lake is about 399.1 feet. Okay, those were the two warm-up problems. Hopefully you were able to do them. This one was definitely the harder one to do. You'll see one like it on your Kansas math assessment. So you will want to know how to do that. When we're talking about right prisms, we're talking about a prism whose side is perpendicular to its base. That means it goes straight up and down. Okay, now what is really neat to know is that even if it's oblique, which means it's pushed sideways like the Leaning Tower of Pisa, you still use the same formula. Your volume is your base area times the height. So the area of the base times the height of the prism. So when you get ready to find the area volume of this triangular prism, triangular tells us what the base should look like. There's your triangle. Step 1, find the area of the base. The area is found by using 1/2 b times h, or bh divided by 2. So your capital B, your base area, is 6 times 10 divided by 2. 60 divided by 2 is 30, and that would be feet squared. Okay, your height is the distance from one edge to the other. Okay, you've got your base area, you have your height. Let's put it all together to get our answer. 30 times 17 and we get 510. And this would be feet to the third power. Feet squared times feet means feet to the third power. Okay, if we've got a box, the volume, it's called a rectangular prism. And this is probably the easiest one to find because your volume will simply be length times width times height. You've got three numbers. All you're going to do is multiply them together. Does it matter which we call the length and the width and the height? No, because I can turn that box around and it still has the same numbers. So our volume will be 6 times 9 times 4. (216) centimeters to the third power. Your volume is always, always, always to the third power. Okay, the area of a regular polygon. 1/2 of your apothem times your perimeter. And that would just be how to find the area of the base. So if your base looks like this, your apothem is the same. I always think of it as being the same as the radius of a circle. So this is your apothem. So to find the area, 1/2 times 15. What is our perimeter? The perimeter is the length around. So this would be 18, that's the length of one side, times 1, 2, 3, 4, 5. So if you notice, I don't even try to simplify anything. Okay, now I can either multiply by 1/2 or multiply by 0.5 or divide by 2 when I get done multiplying, and I will still end up with the correct answer. So 0.5, that is the decimal representation of 1/2, times 15 times 18 times 5. 675. And that will be units squared because it's a flat surface. It's only got 2 dimensions, length and width. It doesn't have height. So that is units squared. Okay, so we've got 2 different prisms to find the volume of. The first one we'll do first. So for our base area, we will use 1/2 of AP. Okay, your A will be 4. Your perimeter will be 8 times 1, 2, 3, 4, 5, 6. So 0.5 times 4 times 8 times 6. And you get 96. Okay, now we have to know the height of the prism. Our height is equal to 8. So for my volume, 96 times 8 and I get 768, and that is inches to the third power. Okay, pause the video. Can you do the triangular prism by yourself? Can you find the area of the triangle and multiply it by the height. I do hope you tried. So let's find our base area first. 3 times 6 divided by 2. 18 divided by 2 is 9. Our height is 2. That's the length from front to back. So our total volume is 9 times 2, which is 18, and this will be meters to the third power. Okay, I hope that you are understanding how to use these formulas. Your volume is all formula driven. Base area, the area of the base, times the height. I know I'm successful when I can find the volume of any right prism.